Okay, the topic for today will be using data to predict stock prices, a very exciting topic for to cover. Just a few ground rules before I introduce our speaker for today. For better audio purposes, we have put everyone on mute throughout the session. If you have any questions along the way, please feel free to type in your question at the chat below, and our friendly teammates will direct them to the speakers. There will also be a short briefing on our Master of Science Data Science program awarded by University of London after the masterclass today. Allow me to introduce the speaker for today. Professor Robert Zimmer is the academic lead of Goldsmith Worldwide at Goldsmith University of London. He studied at MIT, Cambridge University, and Columbia University, where he received a PhD in mathematics in 1985. He began his research career developing mathematical methods for hardware and software system security with applications to safety critical systems, including nuclear reactor protection systems. He has gone on to research on various subjects such as artificial intelligence and digital art theory and practice, as well as financial mathematics and financial technologies. They are the subject of this talk. So without further ado, let us welcome Professor Zimmer. Professor Zimmer, over to you.
Okay, everybody. I'm going to talk to you about something that I talk about in one of the modules. We'll talk about the module structure later, but the module I'm talking about is about predicting values of time-based data, and stock prices is one of those things. Now, so I'm going to talk in general terms about how data science might be useful in predicting stock prices, and then we're going to dive down into one particular way of doing it, and the way of doing it comes from the module I teach, which is called financial data models. So let's see if I can share my screen. So this screen I need. Okay, can you see my screen now? I'm assuming you can. Somebody will tell me if you can't.
Yes, it's fine, Rob Zimmer.
The screen here is now, it's not a PowerPoint. You'll notice that straight away. It's what's called Jupyter Notebooks, and it's a way of having Python code. Or there's other versions as well, but the Python version is what I'm using. Python code sort of living with text, so you can have that together. And the way I usually do my lectures is I do them in Jupyter Notebooks in real time, and I do the coding, and I do, well, some of the coding on real time, but definitely most of the compilation in real time. So I type and I compile while I lecture usually. I'm not doing this today because I've been having problems with technical things. So I've already compiled this, but just to say that's why it looks like this and not like a PowerPoint presentation, because I would generally be typing and doing programming with you and as I speak. So we're talking about ways in which data science is useful for trading shares or for predicting stock prices. Okay, and there's two general ways people think about predicting stock prices, and it breaks down into what's called fundamental analyses and technical analyses. And fundamental analyses are when you're actually looking at things like what the company is doing. So you're looking at things like, this looks a good company, I think this is undervalued, the good management, things like that are fundamental things. And you might look beyond the actual share itself, and you might look at the sector or the market in general, and you might say, I think, for example, oil prices are about to shoot up because of the invasion of Ukraine, for example, and you might have used that to decide that investing in oil companies was a good idea at that point. That's not a technical analysis, that's a fundamental analysis. It's analysis around the kinds of the values of the company itself and of the market. Now, technical analyses are different, and they don't look at anything but the prices themselves. So what we'd be looking at in this case is you look at the patterns in the share prices and you say, this kind of pattern generally leads to this kind of effect. And so both the technical and fundamental analyses lend themselves to data analysis, to data science, by looking partially at how things have happened before in the past. They both involve making predictions based on what's happened in the past. But the technical ones, which is what we're going to look at now, just looks at that. It doesn't look at any information aside from the history of the share prices. Okay, so you're saying this is going up. I think it might still go up more. This has just gone down, and I've noticed looking at the pattern of this share in the past that generally means this has gone down about as much as it's going to, and so on. So you're looking at just technical analyses. Just look at the share prices themselves, and there's lots of data science techniques for both of these, and we learned a lot of them in the program with statistical analyses, deep learning, recurrent neural networks. All of those come up in the program one way or another. Kalman filters, I do Kalman filters. That's really useful for certain kinds of predictions. Looking at sentiment analysis, so you might look at, say, what people are saying about a share on Twitter, and that might give, or what people are saying about price of oil on Twitter, or whatever. You might do some analysis of positive and negative comments on Twitter about something, and that might make you think, there's a lot of people saying good things about this at the moment. I bet it's going to lead to some people buying things. So we teach you how to do that. We talk about using natural language to understand what's happening in Twitter, for example, and there's a social networks module that also talks about that. And so you might use that as a way of deciding whether where you're going to put your money in the stock market. It's not what we're doing today. Today, we're looking at just the technical analysis, looking at the share prices as a series of values, and what we think will happen just as a series of value. And what we're going to use here is called order regression. Now, some of you may have heard of linear and multilinear regression. That they're very standard techniques in data science and computer science altogether. One of the things that I'm always pleased about is when I get in my modules, when doing a particular thing, to talk about an important subject, and which has a lot of application throughout computer science, and linear regression is one of those. So we'll talk a little bit about linear regression today. And order regression is just a version of linear regression where you're just learning about yourself. That's the order bit. So this again goes back to what I was saying, that I'm looking at these time series just as a series of these values. I'm not looking anyplace else. So I'm looking just within this series of values as for all the information I'm going to get. Okay. So the motto for my courses comes from T.S. Eliot, was time future contained in time past. The idea here is what's going to happen in the future. The past will give us the key to what's going to happen in the future. So we're just looking at the past as a way of saying what's going to happen in the future. So we're going to look at what we think the next stock price is going to be as somehow a function of previous stock prices. That's entirely what happens in my module. We're talking about one particular way of that in this lecture. Okay. Okay, so we're going to actually do some programming. Though, as I say, I've already cheated and compiled it all, which I wouldn't have done, except I'm a bit worried. Okay, so I don't know how many of you know about Python. If you do this program, you'll know a lot about Python by the end. And I'm going to tell little bits of Python as I go here. Pandas is the Python library for data science, and it's really, everybody uses it really for, at least for displaying things, and we'll talk about that as it comes up. This is just for graphs, and actually we don't use stats models in this. Okay, now where are we going to get our data? All my modules use real data. We don't make up data. Okay, well, except occasionally for an example, but mostly we use real data. So Y Finance is Yahoo Finance. So this is looking at the Yahoo Finance pages or whatever this system, and it's taking a ticker with TSLA is the ticker symbol for Tesla. Some of you will know. So this is just taking, this ticker is Tesla share prices and share lots of other things, which I'll show you in a second. The ticker has a lot of information in it. But this is real time or almost real time data. Yahoo Finance tends to be about 15 minutes behind, but besides that, it's entirely real data. And just to give you a sense, I'm not going to go through this. There's incredible lots of stuff in this ticker. See all of this. God knows what all that is. But there's a lot of stuff there. But part of it, I'm going to look at a part of it that's called the history. So this part always means that this part on the right belongs to this thing in the left. It's what's called object orientation. So this ticker is an object, and history is one of the things that is part of that object. And then the history is, we can look at here, that look better. We've got this, this is just giving us the opening for each day. This is all, you see, this is all, each row is a day. The high for that day, the low for that day, the closing value for the day, the volume for the day, and dividends. There might be other things as well. Yes, and whether there's splits or not, which there recently has been for Teslas, it happens. Okay, so that's what I'm interested in. I'm interested in the prices. I'm not interested in that other stuff at the moment anyway. So, and what I'm going to take as my main data is the closing price. I'm not going to worry about the highs, lows. Certainly not going to worry about the volumes. That is interesting as well, but not for today. Okay, so this is what this is telling me. I'm going to take this whole thing I've done, which is called a data frame, and I'm going to take the history of starting from 2014 and going to 2022 March, and I'm only looking at the closing prices. That's what this bit says. I don't know if you can see come to think of it, but so I'm calling that observed. So my observed values are going to be closing prices within this period, okay? And some of this is going to be training data, and some of it's going to be test data. Most of it's training data. I'm using 2014 to 2021 as training data, and here, so here's the training data. We can, and oh, I'm going to tell you another thing. This is not actually the Tesla price. You might have noticed this is the log of the Tesla price. Now, there's good reasons for using the log of the Tesla for this analysis, and then to exponentiate at the end to get the value you started with. I don't know how many of you know much about logs. You probably have all heard of them. I'm not going to go through here why it makes sense, why at this point we are using the log, but there's good technical reasons. And if you do this module, you'll find out what they are. So I'm using the training data. For the training data, I'm using the logs. And then I'm going to use the training data to do an order regression on. So I'm going to talk a little bit about what an order regression is. First, in the case of order with what's called a lag, one previous value, and then I'm going to move to more detail, more general. Okay, so I haven't shown you a graph. I thought I showed you a graph of the Tesla prices over time. Usually when you see a graph, you see the x-axis is time and the y-axis is the value. And if you looked at this one, and we'll see it later, what happens to Tesla in this whole period is it goes zooming up till essentially November 2021 and then collapses, which is pretty much what happened to the whole the whole stock market, but particularly the technology stocks. But I'm not going to look at that graph. I'm going to look at a different graph, because remember I said what I'm interested in here is not so much the graph as the value as a function of time, but the value is a function of previous values. Okay, that's the trick here. So what I'm doing here is I'm saying I'm going to take the x value. The x here is yesterday's price, and the y here is today's price. So this, I'm looking at the price of Tesla as a function of the price the day before. And that has this very nice line here. And what linear regression does, or what regression does, is it looks for the line that best fits these points. This is called a scatter graph. Each of these is a point, and you can't see them all because they're quite near each other, but they're all points, they're all circles. And what you want is a line that's nearest, that minimizes the distances between those circles and the line. That's essentially what you want. The vertical distance is actually good. Okay, now that's AR1. AR1 would just be that, and you can see that. That's easy to see what you're trying to do. ARP is the same idea, but it's not using a line anymore. It's using a hyperplane, so I can't draw it anymore. But it's the same idea. You're looking at the present price as a function of the last P prices, where P might be any number. We're going to use 3 today. And we're just trying to find the values of the plane, a hyperplane, that is nearest that scatter points, those scatter points. That's exactly what we're going to do. And another way of looking at it, algebraically instead of geometrically, is we're looking for this. We're going to predict the case value of P, and the hat on top of the P means it's a prediction, as a linear combination of the last P values that I've observed. So the PK with a hat is a prediction. The PKs without a hat are observations. So I've got P observations here, and I'm doing some linear combination of them. So it might be 1/2 times the last one plus 1/3 times 2 before plus, I don't know if you can see that, that might be no. Plus, it's various other, plus 1/3 times the one before that, or some combination like that. Okay. Now, so the question now I've got is, that's great. I see what you're trying to do here, but where are you going to get your alphas from? That's where linear regression comes in. So, or multilinear regression. So this is the famous formula for linear regression. Now, I'm not going to go through this here. What happens in the modules is I do all this programming, and you do some as well. But you also can use this is a library. You can use a library function, but I don't start with library functions. I tell people where they come from, and then they can use library functions if they want. But I explain really what this is. This, for those of you who've seen this before, this is actually or are interested. This is a matrix equation, and there's a sort of mantra here at the last bit which says then this is a linear regression formula, and it's quite lovely. It's one of the nicest formulas I know. It's X transpose X, whole thing inverted, X transpose Y, and that's all that says, and it works, and that does it, and that does the optimization. So now this function I've defined here, train AR, I'm going to use the training data I've told you, which is the not in the last year, everything up to the last year of the Tesla, and I'm using 3. It's going to be, this is an AR3 model. And then what happens is I do this computes the coefficients. That's what this does. This computes, this whole thing here computes the best coefficients. It computes what's called it computes a vector of the best coefficients, but don't worry about that. It just predicts the best coefficients. So these are the coefficients I've got for my AR3 model. Okay. Now I'm going to use those coefficients to do predictions. That's the point, right? That's the point of doing this training. I've now got these coefficients. I'm going to do some training. I'm going to now do some predictions. And what I'm going to predict is for each value, I'm going to predict the next value to be this times the last one plus this times the one before plus this one times the one before that. Okay. I mean, I couldn't do this by hand, but where this came from, but this came from that formula. And then I do the predictions, and then the graph here, but okay. And so I do these predictions and using all of this, and let's see, and let's get down to the graph. Okay, this is observed, and we'll open this in a new tab. So here's the observed values and the predicted values. It's just just 5 of them here, but we do it for the whole year and a bit. Okay, actually. Okay, and here's a graph. Okay, now this graph, the blue is the observed values, and the orange is the predicted values. So this is the prediction. This is using that AR3. This is what for each one, what I thought it was going to be, and the blue is what it turns out to be. Okay, so that looks a pretty good prediction. Now, what I'm going to do is now going to come up with a trading strategy where I use this to actually do something, right? So here's a simple trading strategy we're going to use. We're going to use the AR3 to predict the next value, and then you're going to use that prediction to decide whether we're going to hold any Tesla that day or not. We're going to hold Tesla on days where we predict it's going to go up by 0.4% or more, and we're not going to hold it if not. And when I say not hold, we're going to sell if we have it, and we won't buy on days where we think it is going to be 0.4 or more. We're going to buy or hold. We're going to keep it or hold. Okay, so that's what the strategy is, and that gives me a Boolean is holding. So this is going to be is holding if and only if the predicted value is more than 1.004 times the observed value before. So this shift is telling me this is yesterday. The shift tells me yesterday. So if my predicted value for today is more than 1.004 times my yesterday's value, I'm going to hold, otherwise I won't. Okay. So this is what my data frame looks like now. I mentioned data frames before. They look a bit like spreadsheets, right? So we've got this is the index really, and then we've got 3 kinds of data here. We have the observed value, the predicted value, and whether we're going to be holding or not, which is a Boolean. Okay. Right. Okay. Now I'm going to keep track using that strategy. I'm going to keep track of the value of my portfolio. I'm going to start with $10,000, and what happens to the value of my portfolio each day? Well, on days when I'm not holding, it doesn't change, right? So it only changes on days when it is holding. So that's what that if function is here doing. And how much does it change? Well, suppose this share price doubled from yesterday to today. Then what would happen to the value of my portfolio? It would double, right? So that's easy, but it doesn't happen many days. But suppose it went up by 5%, then what would happen is I take my portfolio would change by multiplying its present value by 1.05, and that's exactly what this does. This saying I take my closing the value and divided by the last price, and that will give me the 1.05, and I'm going to multiply that by my old value. That's what times equals means. Take your old value and multiply it. The times means multiply plus you do the same sort of idea. Take your old value and multiply it by this. That's what it says. That's how that to read that. And then I'm just going to keep track of that and look at the equity values. And then I've got here now I've got the equity value, which is another column I've got my data frame. So I've got my observed values, my predicted values, whether I'm holding or not. On days that I'm not holding, you can see I haven't changed the value. On days that I am holding, the value does change. Okay, sometimes it goes up, sometimes it goes down, depending if I'm right or not. Okay, so, right. Okay, now I'm not going to go through this code, but I'm just now making graphs of what's happening here. So here's my graph, nice colorful graph. Right, now, this graph is color-coded to tell me when I'm right, when I'm wrong, and when I'm not holding. So if it's yellow, I'm not holding any. I'm not holding. If it's blue, and I'm holding, and if it's blue, I'm holding and I was right. If it's pink, I'm holding and I was wrong. So you can see this is going down when I'm holding, right? You can see this is going up when I'm holding. So that's how to look at this graph. So this, and the blue line is actually the value of the share. Now, I'm hoping you can see this. I can't see this all the way through myself. But if you look, the share value at the end of this period is pretty much exactly where it is at the beginning of the period. It's almost identical. It happens to be a period where there's some falling, some rising, and then some falling again, and it gets back to where it was. So if you had just bought Tesla shares here and just held them, you would be unhappy for a while. Then you'd be happy, and in the end, you'd just be where you started. Okay. This, on the other hand, is what happened to our portfolio. It also was, not surprisingly, when things were not so good, they weren't so good either, because I'm not shorting anything. But what you find at the end is, I can't see the end here, but your $10,000 is now worth about $11,000. So you've actually made about 10% over this period, even though the share price is pretty much the same at the end as it was at the beginning. So if you just held the share, you would not have made $10,000. You would have made nothing, I think. But by using the strategy, you would have made however, $1,000. Okay, so I'll be a bit honest with you here, though. I had to pick this. It doesn't always work. Works sometimes, doesn't work other times. But here it is working. Okay, so that's all I wanted to say, really. Let's see. Okay, good. I'm back on screen. So just to give you the idea, in the whole program, you learn lots of techniques for doing lots of things, and share prices is one of the things you can use it for. There's lots of things around natural language, things about being able to classify visual things. There's all sorts of other things as well. It's not all share prices. And it's not, my stuff isn't all share prices either. So there's stuff around global warming that I do, and stuff around various other things as well. But the techniques are useful for all sorts of things. In the module in particular, we look at time-based things. Other modules look at visual things, look at natural language things. There's all kinds of other things that happen in the program. And as I said, I mean, different people lecture in different ways, but my lectures tend to be a little bit like what we just did, but I tend to do the programming as I'm lecturing. So you get to see me programming. And in my program, my module, then I'd expect you to do some programming, but you also can mostly use library functions. But I want you to understand where these library functions come from. That's a really important part of what I teach. Okay, and that kind of moves us into later when I talk about the program in general, that we're really important that you understand principles. You could understand today's technology and how to use today's technology, and that's really great, and you should do, but you really need to understand the principles underlying that technology so you can work out how to do things, how to deal with things when things don't quite work, first of all, and secondly, the technologies will change, but the principles won't change nearly as quickly. So if you understand the principles, you can change with the technology. Okay, are there any questions?
Thank you, Professor Zimmer. Thanks for the insightful take. We will now take questions here if you have any questions for Professor Zimmer. So we do have a questions from Jaden earlier. So his question is actually, what are the main limitations of the AR model? Professor Zimmer, please.
Sorry, say that. I missed that because I was reading something. Sorry about that. What was that?
Oh, the question is, what is the main limitation of the AR model?
All right. Well, the AR model it needs a sort of regularity in the data. It's actually stock prices are a very difficult thing to predict. Stock prices are really kind of out there as an outlier in unpredictable things. So the AR models really work better or more reliably on things that change more gradually. But they do tend to be useful, and if you do any model really about this sort of thing, you'll find that what happens with AR models is they get embellished by other things something called moving averages and something else called integration. It's something so AR becomes a REMA, and that takes into more of the sudden changes than AR is. AR is really much better for gradual, predictable change than it is for other things. So you wouldn't really use AR probably as in the end for doing your you wouldn't rely entirely on AR to do stock market predictions, though it is really good at some other things like as I said, like tracking global warming, predicting global warming, for example, which is much more gradual and predictable. So yeah, but so it's AR tends to do the more gradual, predictable stuff. It gets embellished, and you'd learn this in this course with things that deal with sudden shocks better. That's what the moving average is for. And the integration it's to make it more what's called stationary. So you put all that together, and really what the AR is just one thing along in the lines of what we would be doing in what you do in the module. We do what's called decompositions that include AR, but also include other things as well. So it's just the AR in itself is not the be all and end all, but it is on the way to being. It is part of what's useful. Yeah.
Thank you, Professor Zimmer. So I believe it answered your questions, Jaden. Yeah. So we have a next question from Joycelyn Wong. So Professor Zimmer, have you compared this with predictive machine trading system that are already in the market?
Not as such, because I'm not really thinking of marketing this, but we do a lot of analyses of various kinds of techniques throughout the module. And in fact, in the module, what the main work of the module, if you're a student, is I expect you to produce a portfolio where you do 7 different techniques and you compare the results, and then you can compare those with and then you have that's 70% of the marks, and there's 30% to do what you want. And different people at that point look at more at technical analyses that are more standard, including off-the-shelf things that you can get as part of Yahoo Finance, for example. So yeah, I mean we do that. All of these predictive models have their pluses and minuses. And what I'm trying to get people to do is in that portfolio to discuss what works under what conditions each of these methods works well and which ones it doesn't work well. So yes and no is the answer to that. I don't do that as such in the lectures, but I expect people to look at that as part of their coursework. And I've looked at it some, and I can see in some ways that some things work well, and some ways that other things work well.
Thank you, Professor Zimmer. So I hope you answered your question, Jocelyn. Yeah, we do have another question from Max. Max question is, have all opportunities in short-term trading time frame have been arbitraged by HFT if there are any alphas to be generated by an individual using data science techniques?
I think so. I mean, so, I kind of get the point, but yeah, I mean, but you have so all this stuff is out there, and used in different ways, but people, there is still money to be made and money to be lost, and you can. I think that understanding data science techniques can give you an edge in some of this, even though, as you say, that the market's kind of already uses them. So you otherwise that is kind of an interesting thing. What the effect is there goes both ways. It's a reason to and a reason not to. Yeah, I think that's what your question was.
Okay, thank you, Professor Zimmer. I think we have time for one last question from Chong. What other time series methods will we learn in the course?
Okay, well, as I said, you use ARIMA, you learn seasonal decomposition, you learn moving averages, you learn Arch and Garch for if you know what that means. It's for dealing with differences in standard deviation along the time series. We learn there's quite a bit on Kalman filters as a way of dealing with time series. I'm missing beta. So what do you call that? How to deal with multiple time series together using beta, if you know what that means. So yeah, it's an interesting question because in a way, if you picked up most books about time series analysis are written by econometrics people. And we use more or less the techniques, plus I add some computer sciencey stuff as well, like the Kalman filters, which you won't see in an econometrics book. But the econometrics books tend not to talk about what's happening at the level of the maths and the level of the computation. They tend to say, okay, well, here's some statistics, and here's how you can find this in this function in an R system or in a Python system, or possibly even a MATLAB system. But it's kind of we look at it differently because I'm a mathematician and computer scientist. Whenever I see one of these techniques, I don't say, where can I find it on the Python system? I say, okay, what are they trying to do, and what does the mathematics look like? And I grapple with that before I give you your lecture. And your lecture is then based on my grappling with what the underlying principles are here. What are they trying to achieve? And then I try to make my lectures tell you that. But then, as I say, you can then use just as if you were doing other kinds of courses, you could then use the library functions that are there, but I just want you to know what they're there for, really, in a way, why they look like they are, what they're actually doing, not just how to use them, but what they are. So a lot of the techniques are the standard econometrics techniques, but they are done with a much more computational mathematical sort of background, but not necessarily, you don't necessarily need to use that maths when you actually do the coursework. But I think it's important you see it, because That's, to me, that's what education is. It's understanding the fundamental ideas. Okay. Anyway, I think have we run out of time for this bit?
Hi, Professor Zimmer. Thanks for the answer. We do have one more question. Do you want to address it now, or you want to wait after?
Yeah.
Okay. We have a question from SYK002. So, for the example you shown, the gain is around 10%. May I know what is the typical gain in terms of percentage per annum for a successful prediction model?
That's I don't know the answer to that, and I don't even know the answer to how I would look at this necessarily as a long-term model anyway. But it'd be interesting to do that analysis over different stocks at different time scales. What would count as success depends very much, I think, on the year. I mean, in the last few years, just holding stocks if just holding technical stocks would have got you 15-20% returns. Not now, obviously. Since November 2021, just holding stocks has meant losing 40%. So I think beating the Standard & Poor's index would be a pretty good way of saying you're doing okay. Does that answer your question?
Thank you, Professor Zimmer. Yeah, so
10% per annum, 10% per annum is not easy to pull without predicting anything at all. It depends on the year. It'd be very hard to do this year. Right, okay.
Thank you, Professor Zimmer. So next up, we will move on to the program briefing. So Professor Zimmer will take his time to share about our Masters of Science in Data Science awarded by University of London. Professor Zimmer, over to you.
Right, okay. Now I've got to hold on. Have I got a screen with that on it now? I have to bring up PowerPoint. Hold on. Sorry about this. Okay. Can you see that now?
Yes, we can see it, Professor Zimmer.
You can see it.
Yes.
Okay, I've got one thing. I've got to get a charger. I might have a charge. Okay, so so what can you see now? You can see my screen. You can see the PowerPoint presentation. Is that right? Oh,
Yes, Professor Zimmer. Yeah, we can see the slide right now.
Right. So you don't see me anymore. Is that right? Okay. Right. Okay. So. Right. Okay. So I'm going to talk a little bit about the program. I've already talked a little bit about the program, but we're going to continue that. Okay. So the MSc has been now running for a couple of years. The way it works is it's run by the University of London, which the University of London has been running distance learning since the 1850s. It's actually the oldest provider of distance learning in the world, I think. And the way the University of London works is it's a federation of different colleges. And Goldsmiths is one of the colleges of the University of London. And Goldsmiths has been producing the computer science and material for the University of London distance learning for a very long time now, certainly well over 20 years. And it's grown substantially over the last couple of years. And one of the ways it's grown is that we have this MSc in data science. Okay, and the idea is, as I've said before, we use the techniques that are used in industry, we use the software that's used in industry, but we also help you to understand the principles behind all of that software. So it's important for you to understand present techniques, but also for you to understand what's behind those present techniques. And that's what we're trying to do. We also have a number of kind of application areas that you learn about as well, including the financial ones. So why study data science? I think this is pretty much of a no-brainer, but everybody knows this. Understanding data is kind of the literacy of the 21st century. Everything relies on data. All industries rely on data. It's not just the obvious ones like marketing and finance. All kinds of professions now rely on people being able to understand data, to how to find data, analyze data, and put data in a form that people can understand, visualize, or another modalities. But somehow you want to be able to do all of those three things. You need to be able to get data from someplace, turn it into something, turn it into real information, and then give that information out in a way that people understand, whether that's for the whole world or just for the company you work for. In any case, all of those processes are important. And data science is fascinating, and it leads to many different kinds of jobs. So what sets the program apart? I think it is this idea, this way of marrying the underlying principles and the present practice that's really important to the program. Another thing is there's a lot of different kinds of interactions that I think is really unusual for a program that sort of lives online. So if you were to do this program, at SIM, you'd have access to the SIM lectures, and they're great, but you'd also have some access. The module leaders would speak to you a few times a year, and you'd have a chance of feeding back into the modules. And there's feedback at the bottom of every topic. There's various ways of feeding back. That feedback from students actually does affect how the course runs. So unusually, I think, for an online course, what happens is that you get an input into how the course is running and what happens from there on. That's really important to me, and I spend a lot of time talking to students to try to get that right, both in the modules I teach and on the program, the program overall. So we try our best to evolve the modules to reflect what's happening outside in the world, in the industry, but also on what students want. So I think that's one of the things that does set us apart. Another thing is that the students have a very good network of talking to each other. Students work together quite a bit, and that's another thing that I think is unusual for a program like this. So we look at jobs. We look at what we think the future of jobs is going to be. We keep changing the programs with that in mind. We have to build the skills that in analyzing data and getting data, predicting future trends, and try to get ahead of that. And you learn about present research topics if you do this module, this program. There's a research topics module that tells you about some research projects, and then you'll be asked to do a research project of your own. So everybody on the project, on this module, has to do a project, a fairly substantial project in data science. And we teach you about some of the ways projects work. There's some modules that are very based on projects to get you ready for that. So there's the way the program works. You can get either a full master's degree, which is 180 credits, or a postgraduate diploma, which I think is 80 credits, a postgraduate certificate, which I think is 40 credits. I think that's right. Anyway, but you can look that up online. But there are 3 different pathways, and I'm hoping that there might be more at some point. But one's just straight data science, one's financial technology, where you do the sort of things I was talking about, and one's artificial intelligence, where you do more about the machine learning and deep learning and stuff like that. Okay, SIM starts every October, and the program is devised at SIM to work over 2 years, which I think is about the right time. The way the modules work is that they're 22 weeks long, and there are 10 topics in each one. So there's essentially 2 weeks per topic plus some buffer time for assessments. And each of the topics has videotaped lectures. So there's videotape seems an old word there. Recorded lectures that the module leader gives, and there's usually roughly about an hour of that in each of those topics. Some people do more, some people do less. I tend to do more, and so you have those lectures. Each of those lectures comes with ideas for reading to support those lectures, for activities of various sorts, programming activities or other activities. And so to sort of talk you through it. But if you're studying at SIM, which is, I think, the best way to do this program, you go to face-to-face classes where you get taught by a lecturer, and you have other students that you work with. And so you have both that online content, but also the content in class, which I think is really, really crucial. The people who don't aren't at a teaching center can do it just online through getting web support, but that isn't as great as actually being in a class, I think. Anyway, so there's 2 entry routes. If you have a bachelor's degree, a good bachelor's degree in a related subject, certainly computer science, maths, possibly even economics, then you just can start. If you have a degree in a very different subject, then you have to do a preparatory course that we've laid out for you called K-means clustering in Python. K-means clustering is a standard technique in data science. K-means clustering in Python teaches you some Python, and it teaches you how to use that technique. It's a MOOC, which or maybe a specialization on Coursera, but it's open freely to you, and you do that to make sure you're prepared to start the program, even though you have a background that is not necessarily in data science or related stuff. There's a lot of people on the program with very different backgrounds. I know some journalists on the program. I know some medical doctors on the program. So everybody has a degree of some sort, but they don't necessarily have a degree in something like computer science or maths. So we take that in mind, and we don't assume you can program before you start this. We don't assume you can learn a lot of statistics before you start this. We help you get up to speed from the beginning. So there's 4 core modules. There's statistics and statistical data mining, which teaches you statistics, but in the context of using statistics to deal with data. So it's not just a statistics course, it's a statistics course which is about statistics and dealing with data, and you learn the statistics in that context. Machine learning, where you learn a lot of the standard machine learning techniques. data programming in Python, where you will learn your Python if you didn't know it before, and particularly again in the context of dealing with data. Big data analysis is about some of the standard techniques that are out there in the world now. It's a bit of a challenge keeping that up to date because the topics, because the things change. But big data analysis is that it's about what analysis techniques, and we have a bank of computers here, servers, in which you can do parallel processing using Hadoop and things like that. There's all sorts of things you learn in that program, that in that module about real world techniques. Data science research topics I talked about before. It talks about research, but it also prepares you for doing your project. Data visualization is about how you present data and how you read data that's presented. Financial markets, then in here, the blockchain and financial markets are two of the modules in the financial technologies stream. Blockchain programming is another one I teach. That's one in which what you do is we make our own cryptocurrency, which we call Zimcoin, and everybody who does that program becomes a mining node on the blockchain for that cryptocurrency. So you learn a lot of you learn a lot of stuff about how blockchains work, but you also there's a very hands-on course where you do a lot of programming and become a mining node. And lots of people do that program, that module, and at the end are amazed at what they've done. And I'm amazed at what they do, because people do fantastic work in that module, and it's not easy, but they do it, and it's quite some fun because we do it all together. And at the end we're a blockchain, and we can mine coins, and we can exchange coins and all sorts of things. Neural networks is really deep learning now. It should probably change its name. Natural language processing is mostly is contemporary sort of statistical natural language processing. Artificial intelligence is sort of got two halves. The first half is standard artificial intelligence theory from the standard book by Russell and Novak. And then the second half is a series of, I think, 3 different projects. One about artificial worlds, one about music, making music, have the artificial intelligence ways of making music, and one about doing scientific discovery as artificial intelligence. I think those are the 3. Social networks and graph analysis is brand new. It's got 2 halves to it as well. One is about telling you about social networks, and the other one's doing the actual mathematics of how the networks work as networks. So those work together. R for data science, again, that's in programming. It's the only module that's in R. All the other modules are in Python. So R is just standalone in that sense. So some people, it's actually quite a good module if it happens. Financial data modeling I've just talked about. Mathematics for data science is not started yet. It's one thing still to do, but that's going to be some combination of linear algebra and differential calculus. So again, we have most students do the data science. Some do the financial technologies. If they do the financial technologies, it just affects you. You have to do the blockchain, the financial data models, and financial markets, which actually somehow wasn't on the list before. So those are the 3 particular financial technology ones. And then your project will have to have something to do with finance. The data science and artificial intelligence is you've got the deep learning and the artificial intelligence modules as core to that. But there all of those modules that are core to those 2 are options for the other ones. So you can do the others as well. Okay. so this is, I think we've gone through all these modules, but to get the whole MSc, you have to do 10, 10 taught modules and 1 final project. The final project counts as two modules, so it's sort of 12 modules-ish. And the final project should draw on some of the things you've learned here. And as I say, if it's technology, if it's in financial technologies, it should be about finance. And if it's artificial intelligence, it should be about artificial intelligence. So that's to do the whole the MSc, the artificial intelligence. You've got the big data analysis, and that's necessary for that. Deep learning, the neural networks as well, and the data science research topics. And then again, these other ones are options. The modules, I've already said this a bit, each of the modules, except for the final project, which is 30 credits, all the other ones are 15 credits. They're 10 topics. They're supposed to take a notional 10 to 15 study hours. So a whole module is supposed to take about 150 hours. It's never uniform like that. You'll find that some weeks will take more of your effort than other weeks, but it evens out to about that. I think that's probably about right. As I said, there's an hour-ish, probably now we probably average more than an hour of actual lecture time from the video lectures, and then there's all sorts of readings and activities, and you'll have your classroom stuff as well if you do the SIM. So, as I said, we don't assume you know anything beforehand. Well, we assume you know something, but we don't assume you've done much programming or that much maths. So we have some free material for you that you can do before you start. That should help you hit the ground running when the term starts. And the elementary Python programming is one of it, and some of the background math is there as well. And further information is available both at the UOL website and at the SIM website. This is so. If you do this degree, this is the finances. So you pay some money to the University of London and some money to SIM between the two. So it comes out to this money. So I mean, I'm not going to go through that, but you can. I'm sure these slides will be available to you in other ways. You can find that out anyway, I'm sure. And here's the campus. Some of you will have seen it. I've seen it. I've been there several times, hoping to be there again. And now that the pandemic's over, and over enough for me to be able to travel, I'm hoping to come out and see this. You, if you're students, I hope to meet some of you in Singapore. And yeah, thank you. So questions from me or for the SIM people? Thanks, guys.
Thanks, Professor Zimmer, for sharing with us on the program. We have come to our final Q&A for the session. Here's the time to ask our speaker more questions and learn something new. Once again, please type your questions in the chat. So I believe Sylvia and Chang Hui, our colleagues from SIM, has already answered to most of the questions. Eng has a question: can SkillsFuture Fund be used? Sylvia and Chang Hui, would you like to take this?
Hi, everybody. Okay, so this SkillsFuture, right? That is it the $500 one? If it's the $500 one, okay, thank you. Okay, we don't know that it can be used, so I'm gonna just say no for a start, right? We don't know that it has been used, and partly because our students don't tell us that they have used it. The other one is actually the $5,000 one, right? That at the moment, it is not. The $5,000 one, which is a SkillsFuture Study Award. Yeah. So that is actually well, a lot more in terms of 10 times more money. We had that for some of our other University of London master's programs, but unfortunately, we don't know of any student in our program who has actually used the Skills Future Study Credit. Yeah, Study Award, the $5,000 one. So, so in short, if you do apply and you get it, great. Let us know so that we can tell others as well. Okay, thank you, Chong, for that question. Right. All right. So SIM is actually governed by the Council for Committee for Private Education, CPE, and so one of the things that are required of PEIs, private education institutions, is that we actually put all the list of professors and lecturers who teach in the program on our website. So if you go to our website, I think we've given you the link. You can actually find out more about the teachers or the lecturers teaching on the program. So if you think about it, all right, all our lecturers actually have to have at least a master's with work experience or a doctorate. And in fact, I think most of our lecturers do have at least a doctorate qualification. We do have a handful who are actually very good, but they have much teaching experience and industry experience. In terms of scholarships, unfortunately, I think we don't have from SIM. However, one of the slides that Professor Zimmer actually showed is that the University of London has given what they call a bursary. So that's why the course fees for the University of London fees is there's actually a 30% bursary of the fees which are payable to University of London. So again, I think we very quickly we did have that slide earlier on about that. In terms of bursaries by SIM, yes, we do. SIM does have, I think every year we give out quite a few 100,000 in terms of bursaries to students, and you can apply for it at least once a year. However, just to let you know that for at master's level, we expect many of our students to be working, and usually your household income would not meet the criteria to be awarded the financial aid by SIM. Okay, so anyway, there's information on the website about it. All right, I think the question is about our lecturers, whether they're local or foreign. Many of them are local. We do have Corey Mendes, who is, from the sound of his name, he's not local, but he's based in Singapore, if that's the question you're asking. Yeah, some of our lecturers are actually trained overseas. Dr. Tarapong is, from the name, you can tell that he's not originally from Singapore, but he's now based in Singapore. So we actually get lecturers who are industry experts. I would say, okay, because I'm not a data scientist, I can say this. They are nerdy, which is very much in line with what the people who are interested in the program. I think this is really up their genre. And quite a few of them actually are really into teaching. We have Dr. Peter Leong, who's actually from one of the local polytechnics, but very, very enthused about the program and has been encouraging his students from the poly to sign up. Okay. Nicholas, okay, unfortunately, we don't have a scheme for discount for alumni from the program, but we would definitely welcome you back to SIM. Okay. Okay, so our lecturers are actually trained both locally and overseas. I don't remember offhand where their qualifications are from, but remember what Professor Zimmer says, that actually our students actually will have some contact with the module leaders who will be online and available to assist. And many of them, actually all of them, not many, all of them are based in the UK. Okay. Okay, we have a question about COVID measures at SIM. Currently, all our undergraduate programs are back on site. However, the DS program, the data science program, the master's, is actually a part-time program. So because it's a part-time program, we are a little bit more partial. We actually have a mix. We actually have some classes which will be on-site because we believe that it's good for students to actually meet their classmates and get to know each other and the lecturer. But we also allow the lecturer to discuss with the students and then to have some of the classes online. So this has actually been a win-win situation for the students when we don't insist that they must be online or don't insist that they must be on-site. So again, it really depends on the dynamics of the class. We are very much open to our students in the part-time program staying online part of the time. Okay, classes are actually okay, this is labeled as a part-time program for our students. So that's why it takes 2 years to complete it. In fact, students in our first intake found that actually what is a comfortable load would be to take it over 2.5 years, which means 5 semesters instead of just 4 semesters. The classes are primarily weekday nighttime or on Saturday. Yeah, if it's on Saturday, it's definitely in the daytime on Saturday.
Thank you so much, Sylvia. So I think we have one last question. I think we have time for one last question. So Wei Kun
Correct.
is asking, what are the requirements for GMAT or GRE?
Okay. All right. So GMAT is more for business programs, and GRE, well, it's not for, we don't need GRE and GMAT for the data science masters. So in the UK, as what Professor Zimmer says, most of all the UK master's programs are 180 credits. And basically, they need you to have an undergraduate degree. So there is no requirement for GMAT or GRE because it's not as relevant. Right? So as shared, we actually do, I mean, the university labels them as route 1, route 2. Route 1 meaning you have a related degree, and that there's a whole list of qualifications which are considered related.
Sylvia, do you think we have time for one last question? I think by
Yeah.
Nicholas. Yeah,
Yeah,
Nicholas is
okay.
asking, by attending the masters and we are originally not in data science field, how do we switch our careers when we do not have such job experience?
Well, I think that's what quite a few of our students want to do, and this is in a way an opportunity for you to do. I think maybe Zimmer, you might be in a better position to mention this. It's a step closer towards converting and becoming a data scientist by doing the masters. Zimmer, would you like to take this?
Yeah. A couple of things. First, to go back to the point about the lecturers. All the lecturers, the module leaders are, with one exception, are Goldsmiths permanent staff, and they certainly all have PhDs, and probably almost all from universities in the US or UK, mostly UK. And the question about, I keep getting, and I'm trying to get this to people to share this on LinkedIn, but I keep getting messages from students telling me, I've now got a job as a data scientist, and thank you. I would not have had this any other time. There was somebody the other day who's a data scientist at Google who was thrilled. There's somebody yesterday, I think, wrote to me to say that he's now got a job as as the head of data science for a mining company in Canada. He's Canadian, and this happens all the time. I get people telling me that they're now getting jobs as data scientists, and they were not data scientists before they started this program. So that's something I'm very pleased about, and that's definitely something that we work towards. And so we don't assume that, as I said, that you now have a lot of programming beforehand, and so yeah. and I'm really trying to get people to share this information. And there's a, if you're interested, there is a LinkedIn there's a group for people that you might for this program that I'm trying to get people to share, not just with me but with the rest of the group, these great stories, and I get them all the time. So yes.
Okay, thank you, Dr. Zimmer and Professor Zimmer and Sylvia for sharing, for answering all the questions and sharing. And I hope everyone enjoyed the masterclass. And thank you for spending your evening with us. If you have any further questions regarding the topics of program, please feel free to write to us via email and hotline. I have placed in this chat as well the hotline, our hotline and our email address. Yeah, so thank you and have a great evening.